name is Youssef Moulane. I'm from the Institute of Applied Science. Now it's studied to the School of Applied Engineering Physics here at UM6P. And by the way, I'm also from this region. So this region is Benguris or Hamna. So I'm from here. I got my baccalaureate and my college studies here in this region. So I'm happy to back to this region and to this university to contribute as much as I can to the advancement and the progress of science, and also for this new field that we are having, not new, but in Morocco, so astronomy and astrophysics is not common. We're trying to develop this field in Morocco. So today I will be talking about cosmic consciousness and using the role of Noosphere in understanding the cosmos and also in astrophysics, and there will be a bit focus on the astrobiology side. So first, I would like to, since it's Noosphere conference, I would like to start with this quote from Pierre Teilhard from his book, The Phenomenon of Man. So he says that a particular biological entity such as has never before existed on Earth, so the growths outside and above the biosphere of an added planetary layer, an envelope of thinking substance to which, for the sake of convenience and symmetry, I have given the name of the Noosphere. So this part is getting me excited about giving this talk because Pierre views this humanity as not just a biological entity, but a species that introduces a significant new phenomenon, which is the reflective consciousness, which is very important for us and in astronomy and exploring the cosmos. And that means the ability to think about our existence and our surrounding. So this is exactly what the humanity trying to understand, one of the most important questions that we have ever, but we still did not answer them yet, but we are trying to do our best to answer these questions. And maybe this is not going to be only these three questions, maybe there are more, but I would like to pick these three, which I see that they are more relevant to this, for this conference and for this concept of the Noosphere, and also for us as humanity to explore. So the first one is where we are in the universe. We don't know yet. So given all this advancement of technology that we have and all this thing that we have been doing, exploring and discovering, but we still don't know where we are. So we know we are around the star, planet Earth, around the star, which is in a galaxy. It's among billions of galaxies, which is among amas of galaxy, and then going on until the Big Bang, which we believe that theory that can explain where we are, but we still really didn't know because Big Bang itself is still a theory. And this is really includes some cosmological prediction about the universe expansion. I'm going to talk a bit more about that and the evolution and the survival of the intelligent life. And this is one of the most important axes to talk about in my talk. And also, this includes some philosophical implication of humanity for understanding its place in the cosmos. So the second question is, even we don't understand where we are, so we still did not understand how did all it begin, so how everything was started. And here I will pick the Big Bang that Raphael was talking about, theory that we have doing, and also we still did not completely understand the formation of the galaxy, for the star, for our planet itself, for the solar system formation, and so on. So, and also, which most important recently became, is the emergence of life on Earth and also beyond the Earth. And this is one of the most, what we call now, is the astrobiology. I will focus more on that by bringing the question of, are we alone? So among all of the stars that I have seen now, billions of stars in a galaxy, of billions of galaxies in the universe, so there is this Earth that we are in. So is there only this kind of life that we know, or there is many other kind of life that we don't know yet? And now we are in the age to explore that, and the Noosphere, or the reflective consciousness that we have today, can help us to ask more questions and try to answer this question. So all these questions will help us to guide the scientific research that we are doing today in the cosmic, and in the cosmology and the astrophysics in general. And also, we will need some philosophical reflection. So this is very important for us to understand and aspire humanity to drive and to explore the unknown that we have today. But in this conference, I will not tackle all these three topics, because we need maybe a day or so. But I will just just focus on this last act, which is, are we alone in the universe? I will not promise you that I will give you an answer about that, but we will try to understand where we are within this topic. Are we alone, or finding or looking for the life beyond the Earth? So we did not just started, the story of the science and the story of astronomy specifically. So the humanity, since its existence, tried to understand what's Teilhard say surrounding and what's close to us. So this is start from Copernicus and from what we call the ancient age, and people and polymetrists who proposed that the Earth was the center of the universe. And then we got the Middle Age, or what we call the Renaissance, so where we have a revolution about this topic. So when we got this, some other interesting topic like that the Earth was not the center of the universe, but the sun, and the dynamic and evolution of the solar system, and so on. And until we got to the modern age, when we got in the Middle Age, we got also the gravity by Newton and so on, and then we got in the modern age the explanation of the gravity with different way from Albert Einstein, who proposed the general relativity. And we got Hubble who explained to us how the universe expands and so on. So this was a really long story that drives us today for building the most powerful telescope that we have in the world, James Webb Telescope. And with that, now we can explore more the cosmos and trying to answer this question that I just shown to you now. So we have gotten one of the best picture, and also James Webb will help us to answer many, many questions, including the faraway galaxies and also the existence of atmosphere around exoplanet, which I'm going to talk a bit in this conference. And also we have the first time in 2019, so we got the first picture of a black hole for the first time. So thanks to the technology that we have today, and also this reflection consciousness that we got to imagine what the black hole are. We know them in theory, but we never seen them. Recently, we can see them, and now we're building also a new generation of telescopes, including the ALT, which is most largest telescope in the world. Is going to be built in Chile, by the way, and I had the chance when I was in Chile to visit its first construction. Now it's going up, and I will talk more about that later. So, first, before digging into the topic about are we alone, or searching for life beyond Earth, or astrobiology, I would like to give you this picture of the cosmos and the theory of the Big Bang that we are trying to understand or trying to define. So here I'm showing you this plot, which is, we called it the age of the universe, which is 14 billion years ago. And as you can see here, so everything we believe from Big Bang theory that it started from this expansion, and then we got what we call the inflation. So this is something happened just a few seconds after the Big Bang, and we don't know what exists there, but we still observing now all the galaxies and the expansion and so on, and we're trying to understand back to when the universe was a few years ago. And again, thanks to the technology that we have and to the progress that we got in all this time, so we will be able to observe the universe when it was baby, when it was 380,000 years old. And as you can see here, this picture was taken back just like a few years ago in 2018 by the Planck Observatory. And as you can see here, the temperature fluctuation when the universe was just 380,000 years old. Just think about that. This was really amazing. And now we're more looking in depth to that and trying to understand what's caused this fluctuation in temperature. And we believe that the inflation did that, but we still did not observe that. We're trying to do that through what we call the study of the cosmic microwave background and so on. So let's back to our galaxy. This is, if we want to talk to this topic, so it will take more time, but we will just back to the question that I'm going to explore in this presentation, which is exploring the life beyond and so on. So first, let's start with our solar system, which is what's closer to us. So you know that in our solar system, we have the star, of course, which is among of billions of stars. In the galaxy, I will tell you later how many we have. And we got a planet, what we call the terrestrial planet, among them our planets. And then we got the asteroid belt when we have this Rocky, which I did my PhD. Then we have the gas giant planet and the glass planet because they are far away from the sun. And then we got the Kuiper belt object, or the comets, which also I have been studying during my PhD. So here, just to give you like a bit this picture to show you where we are in the universe and where we are looking for the life beyond Earth. So as Teilhard say that we need to look for life beyond Earth, something closer to us. Of course, we need to understand the life on Earth and then trying to look for the life in Mars and other moons of the other planets in our solar system. But as I mentioned, so if we would like to look for life beyond Earth, we have to understand the life on our planet first. And I will always like to bring this slide because if we want to look for life beyond Earth, what we need for life as we understand it on the Earth, and by the way, could not be only the life that exists in the universe. There might be other forms of life that we are not aware of it. So, but to search for something, you need to define your target. So, and I define always that with this criteria. So, if you need a life, you need this what we call the right chemical elements. As you can see here, the oxygen, the carbon that made us and made our food and everything that we need for life on Earth and for the plants and everything. And also, we need the liquid water. So this is very important because this is one of the most of the driving topic in the exoplanet field. So we look for a place where the water is formed as a liquid, because you see, now we have in the South Pole and the North Pole, so we have water, but it's a glass, so it's very hard to sustain life there. So we need water as a liquid when we can establish a regular life, having plants and everything, and growing things and so on. So also we need the right temperature range. Something is not cold, something is not hot. So we should be in the middle. That's also that we know about life. And also we need an atmosphere that protects us from all this radiation coming outside from the universe. You know, our magnetosphere and atmosphere is really protecting us from the solar wind energy and all this radiation that might kill us. And this is, if we want to look for life for somewhere else, we should also consider in that. And I will give you an example about Mars. And then we need an object that have enough gravity. It's not small, then we can hold things on, and it should be a little bit much bigger, so to have enough gravity, you can build things and grow up things, and so on. And if we combine all of this criteria, we can consider ourselves, we are in the habitable zone. And this is the very simple definition of the habitable zone that I can give. So there are many, because we have found many other planets in different regions and so on. But let's consider this. If we got this element or this criteria, we are in the habitable zone, and the place which has this criteria, it might host some kind of life which we don't know. So if we take it simple, so the habitable zone is a place which is not hot and not cold. That means it's not close to its star and it's not far away from its star. And also it should have like a size around the Earth or 2 times on the Earth. So because if it's much bigger, then it's going to be gas planet, and the gas planet it will be going to be very hard to host some kind of life. So if we want to do some small exercise about that, let's take some other stars, because you know in the universe, all the stars are not similar to ours. So there are big stars, small stars, and so on. So here an example how this habitable zone changed within the, given the size of the star itself. So you can see one, it's our sun. And you can see in that band, there is 2 planets there. There is the Earth, our planets, and also Mars. And I'm going to talk about that, the potential life on Mars. And then we have other planets that we have discovered so far, given their size of this star. And why I'm showing much smaller stars, because the giant stars, mainly they're going to have giant planets, and this giant planet, they're going to be gas planets, and it's going to be hard to find some kind of life. We need to look for life around some terrestrial planets. And this is why we look for small stars, then they can have small planets like ours, and it's going to be easy also to observe them. Yeah, but I like always to bring this picture. So this picture is taken for comet 67P. And why I brought that one, because answering this question about we still did not understand the life on the Earth. And you know, one of the most important questions we still did not understand as a scientist, how we got water on Earth. So how can the water resist all this dramatic event that happened to the formation Earth back 4.6 billion years ago? Even our colleagues from geology could not explain to us how we can sustain water on Earth for all this long period of time. We believe that comet might bring the water to the Earth because these objects are full of water and also of organics. We found now that most of the organic that we have on Earth here on life, that's making life on Earth, they exist on this object. But this is still not clear yet. We are doing many, many measurements on different comets and trying to understand what is the potential role of this object for bringing life to the Earth. And the story is not easy, as I say no, it's maybe much be complicated, and you will see that later. But we are studying this object not only for understand the life on Earth, but also we are studying them to be aware these guys, they might extend the life on Earth. And you know asteroid, we believe all maybe asteroid to be a potential object that disappeared the dinosaurs 60 million years ago. So we're trying to understand the composition, the chemical composition, physical property of this object, to understand how they contribute to the formation of the Earth or to confirmation of the life on the Earth, and also how, because we called them the leftover objects, when the solar system was formed, these guys were ejected, and they stay like a leftover, and then they back to us, and we can use them to understand how the solar system was formed at all. And this will also help us to understand this object if one day we would like to defend ourselves and to define life on this planet. Why I bring this slide, because this is my topic. I have been doing that for like 7 years during my PhD, and I'm still doing that. So, and this is compared, I bring that to compare to the Los Angeles city. So actually we can compare it with other cities around the world, just to say how these guys, this is our 4-kilometer object, how they are big, and they are much bigger other objects that can risk on life on the Earth. And this is another topic that we are developing now in the community, which is called the planetary defense. So I don't have time to go through that, but I want just to bring that to you to know what's important in this kind of objects. So now let's back to the habitable worlds that we are trying to explore and to explore life around. So I'm bringing here some examples, of course, the Earth, and the life not related to the planets, but also can be related to the moons, like our moon, on the moon of Jupiter, the moons of Saturn. And I'm going to explore 2 potential places in the moons, which is Enceladus, one of the moons of Saturn, and also Titan, and which is more or less similar to Europa, which is around Jupiter, and also I'm going to explore Mars. So let's start with Mars. Mars is a very interesting planet. Why? Because it's closer to us. We can go there and explore. So we have spent a lot of money on that to explore the life, and we know by scientific evidence that Mars has supported life at some point. And we know that Mars has water, all these ages, actually no. And Mars has a kind of life which we're still looking for now in Mars, let's say the leftover of the life on Mars. And we are sending a lot of spacecraft. NASA is doing that, the European, they are doing that, to explore the evidence of life that Mars supported. And why we're bringing Mars? Because Mars, it could be our planet, it could be Mars in the future if we did not care about planets. So Mars at some point has life, has an atmosphere, has water, has everything. Something happened to its system of the climate change, and it lost its atmosphere, and it lost all this gradients of life. And then it lost life. And the future of our planet, if we do not care about it, gonna be something like that. And that's really scary. This is why we're studying Mars, and we're caring about Mars to understand what's happened, then to apply that to our planet to avoid all of this. And then we have Titan. Titan, it's one of the most interesting moons in the solar system, which is only the moon that has an atmosphere alongside with the Earth. And imagine that Titan, it's full of lakes, like that we have on the Earth, but not of water, but of methane and many other chemical elements. So we have sent spacecraft, and this picture on the right, on the left was taken for a spacecraft that was died on the Titan, and giving us this nice picture. You can see the rocks there. You can see many other things, and also we explore its atmosphere. We have all the organics that we have on the life on the Earth, which makes its atmosphere, and you know how the atmosphere is playing a role in the life on the Earth. So this is one of the most interesting moons, and in next few years, NASA is gonna send one of the most important mission, which is called Dragonfly. It's gonna be a helicopter, which is gonna fly on the Titan, and the idea is to explore more its atmosphere and also explore many locations on the Titan to answer this question about the evidence of life that could be on Titan. So Titan is also close, so if we will go there, we can go there and explore many places to look also the homogeneity of this planet, even not, and say how it's homogeneous of the supporting life or something like that. And this is one of the promising missions that we're gonna have in the next few years. It's gonna be taking a lot of time because it's very hard to fly something somewhere like millions of kilometers away from us. Now I would back to Enceladus. Enceladus is totally different. It's a moon, but it's full of ice. But we found recently that's not only it's full of ice, but under that ice, or shell or crust of the ice, exists an ocean, water ocean. And this is when we talk about oceans, so we might talk about life. And the most important thing in this ocean that we have seen is the plumes that you see on the, I don't know how I can't point with this guy, But the plumes that we can see here, so these plumes, we found that they have organics too, which can support life. So where these plumes coming from, we believe that they are coming from the hydrothermal vents, that we have them also on the Earth, on the bottom of the oceans. And if we're talking about these vents in the oceans, so we're talking also about life, because we have that in our oceans. So we have many animals, they are living in this extremely difficult environment. So the question, so why they could not exist also on Enceladus? So this is some prediction or some reflection that we can say about that. But it's very hard to go there and check that because the crust is like 100 kilometers. And we still did not have that technology to go and dig and dive to this, create a hole on that. And there is some reflection project that's sending a submarine to Enceladus and try to explore this life there. And this is kind of life. So when we say life, of course, I don't mean humans like us, but any kind of animals exist, so there is life there. And so Enceladus might support some kind of life like that we have in our planet. But this is about the object that they are very close to us. What about the other stars? This is a picture of our galaxy, but not a real picture, an illustration, because we have never been outside of our galaxy to take a picture of it. You might be wondering about that. But this is just an illustration of our galaxy. We observe it from the center, and we are somewhere here. And there are all the bright spots on the slide you see there, they are stars. So the question, how many stars are there in our galaxy? So we have up to 400 billion stars in our galaxy, which is among of billions of other stars. So the question is, are there planets around the stars too, like our solar system? The answer is yes. And Nobel Prize was given in 2019 to Michel Mayor and Didi Geloz. And by the way, Michel Mayor was invited here at our university to give a talk, which won of the Nobel Prize. And they found the first exoplanet back in 1995 when I was 3 years old. So, and this was the first time we have reflection consciousness about the existence of exoplanets, but we never detected them. And these two guys come and found them, and they open another door about this question, or trying to really find evidence or scientifically prove there is a life beyond the Earth, which is around other stars. Now you have also to think in your mind that when you go, maybe at nights, in Greer we have clear skies if you go far away a bit from UM6P. So when you see stars, you have to take in your mind that around each star, there is at least one planet, if not more. And we have now more than 5,000 exoplanets that we found. But the problem, of course, this exoplanet, not all are similar to the Earth. Most of them, or I'd say like 60% of them are giant planets, like Jupiter. Very hard for them to have life. But we found only a few percent of them, that's 4%. But that's enough to look for life around this exoplanet. So I want just to share with you how we detect these guys. The sample is very easy. It's by indirect method. So we have a star. When the planet passes in front of us and between us and the star, so there is a dip in the brightness of the star, and we believe that there is something passed from there, which could be a planet. If the brightness dip if the dip is a little bit higher, so the planet is big. If it's small, the planet is small. And this is called the transit method among other methods that we use to discover this kind of planet around other stars. But let's focus on this planet that they potentially maybe have life. And this is one of the kind of planet that we are interested in. And I brought you here a picture of many planets that we found. That they are in this habitable zone that I have defined just a few slides ago. So, and most interesting, the most closest one is 4.2 light years away from us. And just, I want to let you know that even we found life somewhere else, because we will be never able to go there. Just take care of our planet, and there is no plan B. So, why I'm saying that? Because the closest planet that we have, it's 4.2 light years away from us. That means that if we want to go there, it will take us 4 years if we are going with the speed of light, which 300,000 kilometers per second. We did not have any technology that can go fast with this speed. We have now, I think, up to 1% of the speed. So we will be able dream to go there. So with this technology that we have, we don't know what's going to happen in the future. But just to make sure that even we find life, or we find alternative planets, we will not be able to go there, so we have to take about our climate change and our planet. So among these planets, I want to point out this 4 one. You can see in the middle, and they are similar, TRAPPIST. And why I'm bringing that? Because I was contributed somehow to the discovery of this exoplanet using one of the small telescopes that we have. The one in Chile, in La Silla, is called TRAPPIST-South, was established in 2010. And the second one, by the way, it's in Morocco, here. So in Camden Observatory, it's around Marrakesh, it's called TRAPPIST-North. So the way we are using the two telescopes to detect this exoplanet and also to study the small body solar system, including comets and asteroids. And I have the chance to work on this telescope here in Morocco and also in Chile when I visited back in 2019. So what is most important about the system? It's a star. We found 7 planets at once, not only 1 or 2, 7. But the most important thing about the 7 planets, 3 of them, D, E, and F, the 3 of them, not only one, exist on what we call the habitable zone, which means that they support the liquid water, and they have an atmosphere. And now we are looking for that atmosphere using James Webb Telescope and so on. And this not only the system exists in our galaxy, but there are many others like this one, and this is great, a really potential of exploring this world for life and so on. If I want to give you a picture of this, so if you look here on the bottom, they have the solar system with what we define as a habitable zone. As you can see, Mars and Earth, they are small. Actually, Mercury and Venus, they are not. They are very hot. They are not on the temperature region they have shown, so the temperature up to 800 degrees Celsius, which is very hard for them to support any kind of life. And then all the TRAPPIST system, as you can see, we can fit it just inside of the trajectory of Mercury because their star is small. And then they might less temperature, and then they might can support some kind of life that we are looking for. So how to explore this life around this exoplanet? We detect them. So to do that, we have to look through their atmosphere. And this is very hard technically to do. So because we cannot see the planet itself directly, we just see it through its own star. And how to study its atmosphere? It's again through the light, because what we can observe in astronomy, we deal with lights. We don't see things with high resolution. So, and how to do that? It just we look for the light coming from the atmosphere, and this light it excites or absorbs the atoms that are in the atmosphere. They excite or absorb the atoms, and then they give them this excess that we can observe in our spectrum, and we can see if there is which kind of element that exists on the atmosphere. And the way to do that, we use the technique called transmission spectroscopy, the same principle that we use for the transit method, but this time we observe it at different wavelengths, and that can give us different chemical elements. And yes, we did. And to do that, we need a giant and good telescopes to do that, because we cannot do that with TRAPPIST because it's small. We need larger telescopes to do that, and the humanity is also, again, they are exploring, they are trying to find that, and we are using one of the most powerful telescopes. James Webb have been already launched, and now it gives some, one of the exciting results. And also we have the extremely large telescope, which have been being built in Chile, and it's opening gonna be next year. And I want just to give you information. This telescope, Morocco was a candidate to host it back in 2007. But unfortunately, we could not, because Europeans have a good agreement with Chile. So we was competing with Chile to get this one in back 2007, and they got it because they have already set a contract with them, and they have a good relation. So, and also Chile is one of the best sites in the world, as we say. But Morocco is close to Europe, but well, they win. So we're going to use the telescopes to look for the atmosphere of this exoplanet, and actually we did. We found many other molecules, and we got the water, of course, we got carbon monoxide, we got methane, we got sodium, we got many, many other elements. I don't have time to see all of them or to show all the spectra. And this is one of the first spectra that we got from James Webb Telescope, and we are waiting for more spectra to come when the ALT is going to be operating in the next coming years. But this is not only the thing that we are using to look for life beyond Earth. We are also waiting for some signals that might come from an advanced civilization somewhere else. China is looking for that, and they built one of the most powerful telescopes on that, which is a 500-meter telescope, radio telescope. It's fixed around mountains, and the idea is just to wait. This telescope does not turn its tail like that, and it just waits if we receive any weird signals from some civilization that we don't know. And this is another path to look also if there is some life somewhere else that we are not aware, and we will need be able to go there. So the question is always still there. So if we understand how the life is built on the Earth, so we can similarly explain somehow how the life can exist on other planets, exoplanets. As I mentioned, comets, they might play a role. So you maybe ask, so is there other comets in other systems, and other exoplanets? Yes, the answer is yes, and we found them, and we found even that the comet have some organics or some molecules that exist for life, like phosphorus, so they're found in comets, and also we found it in star-forming region, not in our solar system. And this is also means that the comets, they might play a significant role of delivering the life. If it did it for our planet or our solar system, it might do the same for other exoplanets, and actually we found that. And I will be in a few slides. And now, this was normal up to 2017, a few years ago. And then we discovered what we call the interstellar objects. Yes, this is my last slide. And what the interstellar objects are the objects that are not coming from our solar system, but coming from outside of the solar system. In 2017, we discovered Oumuamua. It's an asteroid. In 2019, we discovered comets. It's called Borisov. And these two objects change the story about if the comet delivered the life to the Earth. This object, they are coming from somewhere we don't know, from around other stars, and they might contribute to the life on the Earth. So that's complicated the question about life. Life never been easy, and the life might come from elsewhere. So that's my takeaways, and thank you very much.